All right, so here is the final part of your final. This is part 3. It will be worth 25 points. And what, we've already done 60 points so far? So 25 more points coming your way. It is multiple choice for most of it. There are a few free response at the end. So your first question that you're going to hit on your final is taking a degree measure and converting it to a radian measure. So as I look through the first 4 questions of your review packet, I realize that is not what I just said. Well, kind of. Part of it is. Which one do we really need to focus on here, guys? If it's degree measure to radian measure, we're looking at these two. So this you do have to have memorized. What do you multiply by to convert degrees to radians? Yes, pi over 180. Now this is a multiple choice question, so that means the nature of the answer is going to be in its finest form, a reduced fraction coefficient in terms of pi. So 405 divided by 180 is what you need to math enter on your calculator, and then tell me what that reduces to. No, really, I don't know, so I need help. What is it? 9 pi over 4, thank you. So that's the sort of thing you're going to be asked to do on question 1, pretty much. Okay, now this next section covers the gamut of law of sines and law of cosine questions. And I think they're pretty basic on the test. There's 1 law of sines and 1 law of cosines. So when I look at these questions, I'm not really sure what I'm looking at until I draw the triangle. So like here, I'm just going to draw a really ugly ABC triangle. Never to scale, never to scale. And then it says angle B is 28 degrees, angle C is 60 degrees, and leg B, which is across from angle B, is 7. So you have an angle side off the top of your head. Anyone know whether this is law of sines or cosines? That's right, class. This is law of sines. You knew that. So you have to start with the proportion part of the triangle that's all filled out. So you would start with B. So you could set up the sine of, B over 7 equals. Now the only other clue you have is this. However, you could quickly find angle A. Let's go back and figure out, what do they actually want from me? They want side C. So it would be smart for us to finish off the proportion with angle C. What mode should your calculator be in right now? Degree mode. Okay, apparently I forgot how to write over the weekend, so let's see how these slides are going to look a little funny, but that's okay. Yeah, right? That doesn't quite look right. Mode. It's all that clapping I did at graduation, right? My hands are dead. I did tear up a little. Yeah. I don't cry. I'm hardened like that. All right, what'd you get when you cross multiply this one? You got 7 times the sine of 60. But then I need you to divide by the sine of 28. Someone tell me what you get. I really, honest to goodness, do not know. I don't have the key in front of me, and I can't do this in my head. Because if you have your packet, could someone just tell me what the answer's supposed to come out to so my slides look nice? Well, you didn't do. Don't say these things to me the day before. Does that sound like an appropriate answer? Does that mean your mode is wrong, possibly? I'm in radian. Yes, you are. Okay, I'm so That's adorable. I don't think so. What if I put that as an answer choice, just to see who I could get? Ah, clearly the leg is -7.
And even -66%.
What a brat. Okay, all right. So number 5 is, I don't know. I got 12.9 feet according to the computer answer key. Did anybody else get 12.9? Yeah, all of you who have the key on the back. I got you. All right, so let's take a look at a different sort of question. Let me take a peek at what we need. Now, back up to this question, guys. If for some reason I needed the other leg, what would you have to have done before you? I mean, there's a couple things you could do, but what would have been the easiest way to get leg A? Yeah, figure the supplemental angle here, yeah, and work from that side of the proportion instead. So just be careful, because knowing me and Hofbauer, that if we were to ask you a question like that, we would probably put the other leg as an answer choice, just to be a jerk. I mean, that sounds more like me than Hofbauer, but that's okay. Just watch out for that, okay? Let's talk about... these are all pretty boring. Let's talk about 11. Another tragically beautiful ABC triangle. And then B is 21 miles, so that's leg B, 29, hello, 29 miles. Angle A is 120 degrees, clearly, I drew that to scale. And then the other clue is leg C is 12. So which sort of a law are we looking at this time? This is law of cosines, when you have the side angle side set up. So if I want to know side A, well, that's convenient because I'm going to be able to find that with a setup of law of cosines. So you set up opposite leg squared equals, and then the leg order can go in any order because you have the commutative property working. So 29 squared plus 12 squared minus 2 times 29 times 12 times the cosine of 120. So again, we're in degree mode still. And then sometimes kids just type this in their calculator and then they get a gigantic answer, and then maybe they don't think twice about that, and that's really sad. So think twice about it. What else do we need to do? We still need to square root that. So please do that. Pretty intense square root symbol. What'd you get? I do have the answer key, but I'm really... What if I set it up wrong just to mess with you? I know, but usually you catch my mistakes. Is it 36.5? Okay, so here's what I remember from not everyone in the class, but a few of our friends who struggled in law of sines and cosines. The typing in was the problem. So if you have yet to type that in as your practice, I think you need to start practicing. All right, so that's law of sines and cosines. Move on to a question down here where it says find the area of the triangle. So you have two area formulas. We have that weird one with the semi-perimeter, and then you have the Heron's formula with it'll kind of use a sine, right? It's like 1/2 AB sine C. I don't know what version is on your formula sheet, but it's applicable to all parts of the triangle. So if you have side, 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 then you're supposed to use that semi-perimeter formula. But if you have side, angle, side, to find the area, you use that other Heron's formula. So we're going to have that sort of a setup here in number 15. Triangle STR, where angle S is 76 degrees, and then leg T is 13, and leg R is 15. Yes, we most definitely have that side angle side setup. So the area formula is 1/2 times the leg times the leg times the sine of the included angle. So legs in any order, and then we're still in degree mode. This time you don't have to do any square rooting, it's just A equals this. So type this in your calculator, and this is number 15, so the answer should come out to 94.6 miles squared. Sounds appropriate. Doesn't have a negative on it, so that's good. You poor thing. I'm sorry.
I went back and checked the test and how did I get that one wrong?
Yeah.
Oh, wait, I didn't change tubes.
So these next couple questions are when you find the area of a triangle when you have the entire perimeter, so that's that weird semi-perimeter one. And you'll notice I'm skipping over this to the next question. Oh, I don't know what that is. All right, so the next thing I'd like to look at is when I give you a resulting component vector, can you find the magnitude? So how does one find the magnitude if you have the resultant? This is just Pythagorean theorem. Yes, it is, Mrs. Abruzzo. So just do that. I still can't write very well. This is scary. Now, if it's a radical, if it doesn't come out nicely, I need you to give me the nice radical version. I don't know why I can't draw a 2 today. What does that come out to? Oh, it comes out nice? Oh, that's beautiful. Okay. I'm not going to promise you it always comes out nice, though. Now, if it's something like this, be careful on this one, guys. When you have -2 times the square root of 21 and you square that, you have to square the -2 coefficient and you square the radical. So this ends up being, like if you typed it in your calculator, as long as you typed it like this, you'd be safe. But I know some of you are like allergic to using parentheses, so be careful about that. And again, -4 squared, you have to square the negative. I think so, you poor thing. That one comes out nice too. Okay. Well, I'm not going to promise you. I'm not going to promise you it comes out nice on the test, guys. If it's like the square root of 29, like leave it the square root of 29. Got it? So more of that. So now I want you to find the magnitude and also the direction angle. So if you wanted to graph this, you could. Let me just take a peek at your test for a moment. Yeah. We're going to do this one. This notation right here is what messed some of us up on the test last time. When it says A to B with this weird little half arrow, remember this has a very specific order to it. So when you go find the resulting vector, you have to take x2 minus x1. It has to go in that order. And then similarly for the y's. So y2 minus, careful, there's a negative here, negative 10. So what I noticed on the last test is some of you forgot that this formula was like super specific. You can't just subtract them in any order. So this resulting vector is negative 5, comma 13. And then I would be a little careful about what this looks like. So your resulting vector is over here. If you want to draw the whole thing out, that would be safe. Now to find the magnitude, I don't even think oh yes I do, ignore me. I thought it was a triple. It's not a triple. Go find the resulting, the magnitude. What number is this, 23? A little funky, right? Square root of 194. The angle is the problem. Can someone remind me how we find the angle? That's right, class. You use the inverse tangent. Internet, you couldn't hear them all scream that at me. All right, so we are still in degree mode because they're going to have a degree set of answers on my final. So in degree mode, what's the inverse tan of 13 over negative 5? That's going to give you something negative, right? Your calculator is going to give you this angle down here, I believe. What does it give you?
It's negative 68.96.
Okay. So this guy is also 68.96 up from 180. So you can take 180 and add negative 68.96 to it, or subtract, however you want to think of it that way. So what angle is this truly? They want the original angle from standard position. It's like 111 or something. I can add 111.0. I just did this. I got that. Okay, got me? So you have to be careful because your resulting vector could possibly be in a different quadrant other than quadrant 1. If that's the case, remember your inverse tangent on your calculator is only going to give you the angle that's either in quadrant 4 or quadrant 1, depending on where you're at. So you might have to do a little work to figure out what your true angle is. I'm kind of taking a peek at your test, and it looks to me like you're going to be in the first quadrant. So yay. All you have to remember is to do inverse tangent and you'll be good. And also to be in degree mode, that too. All right, so then next what I need you to think about is a question like, notice I'm skipping over some things. Let's look at 29. We have a magnitude of 48. And then we have an angle. They kind of wrote this one weird, but the angle is 215 degrees. And they want you to find the horizontal and vertical component. So remember how we find this? It's the magnitude, which they're calling A, times the cosine of theta, and then the magnitude times the sine of theta for the vertical component. So this, and of course, I would probably just crank this in my calculator. Unfortunately for me, I think that might be not the end of my work, because if this comes out a little funky because of a radical, then we're going to have trouble. You know what I probably should do? Can you just find 215 on your unit circle? Because you will have a unit. None of you have your unit circles out. I'll get it. What's the cosine and sine ordered pair at 215 degrees? Oh, that would be why I'm so confused. I was like, man, I can't remember that one. Shut up, Abruzzo. All right.
Where is it again? Where do I look to find it?
I have no idea, apparently. Where is 215? Why am I so confused today? Okay, so in this case, I would just crank it in the calculator. In what mode? Degree mode. Degree mode. Degree mode. So there's going to be a question like this. Where is the answer key? 29. Oh yeah, that's not pretty. Okay, so here's what I'm going to tell you. The one on the test is very pretty. And I would suggest you use the unit circle. Here's what happens though. If you crank it in the calculator and you get something a little funky, not like a nice number that matches any of the choices, what you do then is you go to the choices that have possibilities, like things with radicals in them, and you type them in and you figure out which one's appropriate. Now you could skip the middleman by just using the unit circle. That's my advice to you. Guys, this test is not long. You don't really have to worry about like, oh, I'm going to run out of time if I do it that way. I don't think that's going to happen. You get 80 minutes to do this test. It is like 23 questions. Yeah, there's like a couple free response that we're going to call are worth 2 points because they have like a lot of pieces, like that game board question. Yeah. All right, so anyways, you got to type this in your calculator, and apparently according to your answer key, because none of you typed this in, it's negative 39.32 for the horizontal component and negative 27.53 for the vertical component. All right, there is a question like this when you get to the polar section, which is coming up next. And you do have some stuff on a formula sheet. So I think all I ask of you on the test is to identify the eccentricity. Yes, that's all I ask of you. How do you find eccentricity? It has something to do with this number, right? This number is supposed to be a what in the formula? It's supposed to be a 1. So if it's not a 1, you got to make it a 1. So we're going to divide everybody by a 5. So which number here represents the eccentricity? It is the number in front of the sine or cosine function, which, if you forgot, you would go to your formula sheet and just take a peek at that. So like, mini sheets. Let's see, it was on the polar one? Right, I think it was pink. I might be making that up though. So here the eccentricity is 4/5. Now technically speaking, you should be able to answer some other stuff for me, like what kind of a conic it is, just for funsies. Can someone tell me what conic it is if it's got an eccentricity of less than 1? It's an ellipse, thank you. If they wanted me to find some other things, I could, but they don't ask, so I'm not going to. It was pink. Go me. All right, you are going to be asked to identify which polar coordinate is graphed properly. And don't be surprised if something on the polar coordinate is negative. So please remember that when we're graphing polar coordinates, you actually start with the angle to figure out which radius, which angle measure you're supposed to go to, and then you move out to the rings. So like here, for instance, 3 pi over 2, we know is along here. That would be the positive direction. And they want me to go out positive 2 rings. So boom, boom, right here. But they want you to change this question. Hofbauer suggested that we change this to -3, -60. So it's not going to match the answer key anymore, okay? So if I go -60 degrees, if you can visualize that, that's awesome. If you cannot, then you would just find the coterminal, which means you would add 360 to this. And that's how I figured out we were at, nope, that's, yeah, 300. Get the bifocals out today. All right, so this would be the positive direction if I moved in that angle measurement. But we're supposed to be going -3 rings, so I need you to back up, which for some reason I can't draw a line either. All right, so we're going to back up 1, 2, 3 rings. This is where that ordered pair is located. I feel like I drew that not straight. Is it straight? Looks. I mean, it doesn't look very straight because I drew it, but is it the right line? If you squint, I don't know either. It would be, because, you know, you just add the 180 and whatnot. Okay, we're good. Now, the reason Hofbauer had you change that to have at least one part of it to be negative is because she's warning you that you're going to see that on your test. Okay? So do we have more questions on that? You want to practice going negative in any way? Okay, so again, she had you change some things, so they're negative. So remember, it won't match the answer key if you change this. You're going to have to just trust that you've done it right or compare notes with a neighbor. Do you want to do more of these? Nope, going once, going twice. All right. Converting polar to rectangular. That sounds like something, yes, I totally am going to ask you to do. So what's the formula for converting polar to rectangular? Well, it looks a whole lot like the horizontal and vertical vector formula we just used. So the coordinates would be r times the cosine of theta and r times the sine of theta. So this is a case where I most definitely would want to use my unit circle because the things they're going to give me are going to be off the unit circle. For instance, 2 pi over 3. What is the ordered pair at 2 pi over 3? And I'm really asking for realsies because apparently I'm not going to get anything right. Thank you. I appreciate it. Look at you all just turn and look at her and wait for her to get her unit circle out.
-1/2, comma, the square root of 3 over 2.
That makes sense. So using those for the sine and cosine and using 3 for the radius length, this will be 3 times the cosine. And this guy will be 3 times the sine. And then, of course, it's multiple choice. And no, my choices won't look like this. They're going to be simplified. So this would simplify to -3/2. And this one would be 3 squares of 3 over 2. And that's what you can expect from your test. Okay, something little funky looking like that. You're going to want to use your unit circle, which you do have access to. All right, notice I am going to skip this next part, so read into that however you want. And we're going a little out of order. This question actually shows up later on in the test, but I'm going to carefully select some questions for you to interpret. Find the exact value of this trigonometric function. Find that one. Well, the first thing you have to notice, guys, is that it's -5 pi over 4. If it bothers you that it's -5 pi over 4, so it's like a negative radian measure, and that really bothers me, you guys have many ways you can approach this. Psst, you have a calculator. Like, what could you do? You could, in theory, just type in tangent of -5 pi over 4. In what mode, though? This one would be radian. So if you choose to be a cheater, you better be a good cheater. It's not really cheating. We're just being lazy. And I do it too, guys. And by the time finals roll around, I am just out of gas. So, you know what? My teacher puts a question like that on the test. She's just asking me to take the easy way out. So I'd probably type tangent of -5 pi over 4 in the correct mode, in radian mode. And I'd find out it's probably not a very pretty answer. But guys,
You type all the possible answers.
you could! Or you could just go over 4. That's our over 4 family, right? That's the square root of 2 over 2, dudes. So you just got to figure out based on your sign whether it's positive square root of 2 over... Oh, no, ignore me. It's tangent. It's tangent! So it's even easier, guys. How do you find the tangent of that family? It's always 1 or -1, right? Because it's square root of 2 over 2 divided by square root of 2 over 2 every time.
That's how that works.
I know. But you know what? I'm with you, kiddo. If it came out funky on my calculator, which this one wouldn't, I would just type in my answers to figure out which one matched that funky decimal. Is that the right way to do that? Is that the pre-calc way to do it?
Yes.
No. But is my teacher going to know? No. This is how I was supposed to do it. I was supposed to figure out where 5 pi over 4 is, which means I probably would have added a rotation of 2 pi, because I don't like negative radians. Remember, got to have common denominator, so I would have called this 8 pi over 4. So what is -5 pi over 4 plus 8 pi over 4? That's right, kids, it's 3 pi over 4. So this is the tangent at 3 pi over 4, and then you know what I would have done then? I still would have kind of cheated by grabbing my unit circle and looking at 3 pi over 4, and then finding the tangent. By the way, what'd you come up with? -1. Yes, those of us who just typed it in the calculator got that a long time ago. But remember, tangents are not always pretty like that. If it's a pi over 3 family or a pi over 6 family, it's going to be a little funky.
Can I congratulate her on doing it on the unit circle?
Atta girl. See, you don't even cheat. That's good. I keep using the word cheat. That's a little harsh. It's not cheating. It's being lazy smart. I know, I'm sorry.
I spent my entire weekend learning test taking strategies, and then you call me a cheater.
I call you out for being a cheater. It is, you know what, it's a lot of things. It's, yes. Like, we love that you guys have mathematical intelligence, but like, you know, maybe it's not best to do it the right way every time. You know, maybe.
That's the beauty of a multiple choice test.
That is the beauty of a multiple choice test. And my theory is, and even as a teacher, if your teacher's giving you a test in this format and giving you questions that you could essentially, like, type your way to, they've done that on purpose, guys. Your math teachers, I mean, present company excluded, are very smart people. And they know when they give you a test, like, oh man, everyone's just going to type this in. Or, man, everyone could just type this in. We know. We know. Like how I excluded myself from that. All right, the limits. The limits. We are going to have some limit questions. Give me your plan of attack on this one, guys. Yeah, just plug it in. It's a polynomial. It's totally continuous. So, plug it in. Plug in a 3. Here, 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 and here. Parentheses aren't necessary here because it's a positive 3, but it's a good habit because if I ask you to plug in something negative, you're going to get it wrong if you don't use parentheses. So there's going to be a question as easy as that. There's going to be a question that kind of looks like one of these graphs where it is graphed. Can we talk about one that isn't done here, though? I'm just going to make one up. There was one on the limit worksheet that we did on Friday. Is that the last time I saw you guys? Very large and in-charge ordered pairs I've got here. That's x equals 3. Oh, shush.
It's the power that makes it look like that.
I don't know what's going on in this graph. What if I asked you this? Well, first of all, you have to give me more information. Okay. So you've got this, this weird little curve thing. There's a hole in the middle, and then there's like this random ordered pair that's not in the hole. What happens as x approaches 3? Yes. So you have to remember that it's as it approaches 3 from both sides, it has nothing to do with this extra weird ordered pair that's off in no man's land. It's the approach from both sides of the function on the x equals 3 side. So you were right. The answer should be 3 in that really horrendous drawing. Okay, so this is a multiple choice question, right? So of course my teacher is going to put both 3 and whatever the other one was. I think it's supposed to be a 5. She's going to put both, and that's there to trick me. It's scaled a little weird, but you know, you go with it. It's something. It's an odd power. But actually no, because that's a piecewise function, right? It's got that other ordered pair. Jenna, I don't know. Honey, I don't know. I made it up. It's from my imagination, so there. All right. There's a question that kind of looks like this one, although these are actually harder than the one that's on your test. A rational function. I did, I'm sorry. I'm going to edit that out. The limit here as x approaches 1 is a removable discontinuity, so you'd have to factor and cancel it out before you plug in. The one on the test is even easier. You don't even have to do that. So, you're welcome. Happy birthday to you all. Literally.
Don't expose me to the internet.
Should I shout out to the other one?
No.
Alright. Then, we get to the probability section next on the test. If you guys could please skip with me a little bit to these questions. We'll come back. Guys, I'm concerned about the probability ones because I feel like some of you really messed up these multiple event ones on the last test that we took on this. You randomly pick a marble and then a second marble without returning the marbles to the bag. So this is without replacement, right? So you pick a marble and then a second marble. You got to figure out those probabilities and multiply them together. That's how you approach this question. So you randomly, both marbles are red. That's the question. There's 4 red marbles. So the first time you go to reach in, you have a 4 out of, how many total marbles are there? 4, 7, 11. And then you go to reach in again. What's the probability you're going to pick out a red marble now? There's only 3 red marbles out of a total 10. So you had to take one away from the numerator and the denominator because possibilities and favorable possibilities both were reduced by 1. Okay. So whatever this fraction comes out to is your answer. If it's a decimal on the choices, cool. If it's a fraction, cool. You guys have a calculator. I don't feel bad. Nice. Nice. Goodness of me. All right, there is an or question. Oops, I skipped that one. A jar containing 8 balls, numbered 1 to 8. Cool. You randomly pick a ball. It is numbered 1 or 4. Well, how many winners do you have there if you would win if you chose a 1 or a 4? 2 out of 8, better known as... What? Uno out of cuatro. How do you say out of in Spanish? We're going to have to really expand my language usage here. I don't know either, obviously. All right. Oh, don't tell your teacher that. Okay, guys, there's going to be a matching section where you have to figure out which identity matches which. So it's a lot of, like, swapping and canceling and simplifying. So it doesn't look like an identity per se, but it might look something like this, where you would trade out cosecant for 1 over sine. And you would trade out tangent for sine over cosine. And then after a little simplification, you would realize this equals 1 over cosine. Now, what you would do then is at the top of the section, there's going to be a bank of choices. And you would look at your choices and go, is there a 1 over cosine? And if there is, that's the one you bubble in. But what else could they have called 1 over cosine? Because that's weird. Probably secant. Yeah. So sometimes you're not done simplifying, and that's why you don't see a match yet. So this is going to be a matching section on your test, okay? 3 easy points for everybody. Please. Tell me yes. Matching, yes. Actually, I'm lied. 2 easy points. There's only 2 questions on that. Okay, you're going to be asked to graph secant and cosecant, and not really you graph, you're going to be matching it. So if you really got in a jam, you could use a graphing calculator in what mode? Radian, yes. If you're graphing trig, it's in radian. However, coming up on the test, you're going to have to go back to degree mode, so keep that in mind. Guys, when you have cosecant, the normal period is 2 pi. However, this one has a b value of 2, so this one has a period of pi. And who is the, like, graphing buddy to cosecant? Yes, it's sine's buddy, yep. So what I would do is I would think about what sine of x looks like. And then cosecant would have, oops, the minimums and maximums matching up. So I'm looking for a graph that has a few things. The amplitude line should be at 1/2. So I could probably eliminate some choices here just based off of that, right? No. 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 Oh my gosh, are we done? Oh, so it's either... Oh, geez, that's the wrong question. All right, back over here. I was really Xing things off there. Okay, so it's either C or D. Which one has a period of pi that you just calculated? So it goes through 2 horseshoes to be a full cycle. So that would be this guy right here. Okay. So do I need to grab my graphing calculator for that? No, I do not. Can I? Yes, I can. You do have to watch your modes, yes. Remember, that's our big pep talk. If you want to use your calculator as a binky tomorrow, not tomorrow, 2 days from now, you have to be careful about your mode on your own. And no, I cannot help you with that. All right, so this is a question where they're going to give you a geometric sequence. The one on your test has like some missing blanks, and you got to figure out what goes in the missing blanks. So what I might suggest you guys look at is actually something off of your last test, where like you had like a 4 and then like a blank. Oh gosh, I got to make this up. Hold on. Like this. And I'm going to ask you what goes in these missing blanks if I told you it was geometric. Well, how do you approach that question then? You say, okay, well, I start with a 4, and I hop how many times on a geometric sequence here? Yes, very good. So you go 1, 2, 3 hops. So 4 times r to the 3rd power is going to give you a 1/16. And then divide by 4 and cube root it. So that should give you an r of 1/4. Which now you can go and expand back and figure out what are the missing terms. So 4 times 1/4 is 1, 1 times 1/4 is 1/4, and then yes, continuing the pattern makes a lot of sense. That one was kind of obvious to figure out, like just kind of pushing your brain through it. The one on the test is a little less obvious, but remember, it's multiple choice. So what could you do? Go to choice A and say, does this work? Plug it in. Nope. Go to choice B. Does this work? Plug it in. Nope. Or yes, whatever. All right, moving on. You will see this is now off of the multiple choice part. We are now on the free response on the back, what will be on the back of your test. And there's a parametric equation question where you do get the parametric equations, right? So you have the formulas. It's going to say this right on the question. X equals t times v sub naught cosine theta. And, oops, y equals, I'm going to try to write it in the same order your formula is, negative 16 t squared. What mode are we going to be in here, though? That's right, kids, degree mode. So these formulas are given to you, like right on the question. You just have to know what clues to plug into what places. So for writing our formulas, t is the variable, right? Here's your, where are we at here? Here's our initial speed. So 111 times the cosine of 45 degrees. That's how I knew to be in degree mode. And then for your height, your vertical position, I should say, negative 16 t squared plus t times 111 times the sine of 45. And then there is an initial height on this one. It didn't start on the ground, so plus 44. Calculator in parametric and degree mode. And then you're going to have to maybe adjust your window a little bit, guys. Remember on these, you want your time counting by tenths. So make sure either you set up your window so your time is appropriate and it counts by tenths of a second. If you're looking at your table, that's cool too. This is like it is a non-multiple choice question. And the question that I ask you is, how far horizontally is it when it hits the ground? So in my experience, I find that you guys are better when you trace until you hit the ground. And then if I want horizontal distance, which one are you supposed to be telling me? The x value at that point, okay? So not time, not height, but x, because that's horizontal. Again, guys, it's a free response question. So in theory, you can get partial credit on this one, but not really, because it's only worth a point. Haha, joke's on you. All right, so then, right, isn't it? There's a few more questions. The very first one on the back page of your test is going to be this raffle ticket question. Can we talk about this real quick? It's been a while since some of you looked at the raffle ticket question. So we have 500 tickets, and then they are sold for $15 each, and then there's these three prizes. So a prize, and a prize. You're going to calculate the expected value of the ticket. So what's one thing that could happen here in this raffle? I could just lose. And then what's the probability that I just flat out pick a losing ticket? 497 out of the 500 tickets are just losers. And when you lose, what happens? You lose $15. Boom. Okay, what else could happen? I have a 1 in 500 chance of... I know, this is that subtraction thing that really messes with me. So it's 5,000 minus $15. However you figure that out. And then you have a 1 in 500 chance of winning 2,500 but minus the $15. And then you have a 1 in 500 chance of winning $1,000 but minus the $15. So that can all be typed in my calculator exactly like it looks just there. And I feel like, you know, we're out of gas at this point. It's finals. Maybe double check your work. It's your first final, so it's the best final. I get you. Right? Well, maybe. I don't know. This is the empirical rule question. They're going to want you to kind of sketch. Ooh, look. That actually wasn't too bad. Look at that. All right, it has a mean of 5,000 hours. And then a standard deviation. Does that say 20? Can't read. So they want me to figure out if it lasts more than 500. 500. Oh my gosh. I was about to have a really weird answer. All right, now do not use your calculator on this one, guys. They want you to use the empirical rule. So every time you go up, it's 20. So this is 520, and this one would be 540. So they want to know the probability that it lasts for more than 540 hours. So you guys need to figure out what this probability is. So what you're supposed to be doing is to go look at your empirical rule on your formula sheet. Now, I don't know. Maybe. 2 deviations up, that makes sense. Did you say 2.5%?
Yeah.
Yes, that's what you said. 2.5%.
Okay.
Right? Yeah, 2.5%. So you can just, and I know some of you are like, no, I'm just going to use my calculator. Just be careful. If you use the normal CDF on your calculator, it's not going to give you exactly 2.5%. So with this not being multiple choice, if you write down something else, that means you haven't done what I asked. I asked you to use the empirical rule to find this answer. Okay. And then if they want you to know like how many batteries that are in the sample, then you take that percentage and you multiply it by how many batteries you have. They did not ask you that on this question, and they won't ask you that on the test, so I'll just shut up. All right, moving on. This game board question is actually really, really easy. I know it looks crazy, but it's not. They just want you to compare the probability of winning on all the games. So probability of this probability distribution shown if you get black. Boom. Probability of winning is 3 out of 8. The game board right here, if you get black. 1, 2, 3, 4, 5 out of 9. Okay. And maybe what would be smart is if I change these to decimals. That might be smart. And then careful, probability of losing is 0.66. So what's the probability of winning? 0.34. All right, so this is 0.5 repeating, so like 0.56. This is 0.375. Did I get that decimal right? I know, this is where I'm at today, guys. I really can't even do simple math anymore. Okay, cool. So you would fill in all those probabilities in some variation, and then which game has the best chance of winning? Clearly, that would be game B. All right. I think we got them all. Yay, that's your test. Ace it, everybody.